To make methylamine, I've only needed 3 components: nitromethane, a source of hydrogen, and a catalyst. In my case, I used about 5 grams of 10% palladium on carbon, but others like Urushibar or nickel probably would have worked better. There are honestly a lot of reducing agents that could be used here, including iron or zinc refluxed in acetic or formic acid, but palladium on carbon is what I had at the time, and it seemed like the least chemical consuming option. To make the hydrogen, I set up a making hydrogen flask with 6 grams of aluminum foil and 12 milliliters of concentrated hydrochloric acid. This produced enough hydrogen to fill 1 balloon, and since I used about 3 during the process, my grand total was 18 grams of foil and 36 milliliters of acid. Also, for safety reasons, I flushed all of the flasks with butane to eliminate oxygen and prevent spontaneous ignition. Palladium on carbon can ignite hydrogen under the right conditions, and that was something I really preferred to avoid. As the first balloon was filling, I added 17 nitromethane solution, milliliters of nitromethane to a 250 milliliter flask, along with 30 milliliters of hydrochloric acid. By itself, methylamine is actually a gas like ammonia, holding acid present. It gets trapped in its tablets. It's not volatile hydrochloride salt, which is more than happy to stay in solution. The acid might also act as a catalyst by donating hydrogen ions. But I'm not totally sure with the mixture. Stirring roughly 5 grams of palladium on carbon was dumped in, and this was actually a massive excess. And I was mostly overcompensating in hopes that the reaction would work better. Remember, this stuff is catalytic, so only a tiny bit is actually needed. Some issue, of course. 546. When I first attached the hydrogen though, the excess catalyst didn't really seem to help. The balloon barely shrank after a full day of stirring, which indicated that the reaction hadn't taken place. This made me a bit worried. But then I remember something: in almost every nitro reduction I'd seen, a solvent was used to dilute the reagents. So like any chemist going through a rough time, I grabbed my bottle of alcohol and poured myself about 5 ounces or 150 milliliters. This went straight into the flask. After fixing my setup, the balloon actually seemed to shrink. It took several hours and a few rounds of hydrogen, but this time, success and more issues. The reaction actually seemed complete upon filtering off the palladium catalyst, and I was left with a crystal clear solution, which I boiled down to remove the ethanol, acid, and leftover nitromethane. Things seemed to be going pretty well at first, but then reality struck as the volume decreased. The mixture became darker, and upon boiling to dryness, tar. And I don't think all that color came from residual palladium on carbon. Chemistry is awesome.